For the final video in Module 3, now we need to look at graphs of functions. This is one of those concepts where initially students can become confused by it, but then once you understand what's going on, it actually is not very hard at all. So let me try and lay out what's going on with graphs of functions. Normally, we're given an equation like this and we're asked to graph it. We can graph this one of two ways. This is a linear equation, so it's going to be a straight line, so I can use slope-intercept, or I could just get some points. Let me just use slope-intercept since that's pretty simple. So for this equation, the y-intercept is going to be 4. So I go here, and then the slope is 1. So if you remember how to do this, so there's the graph of this equation. And like I said before, oftentimes they will even on the graph mark that line as y equals x plus 4. But what happens if we use function notation? And once again, to switch from x and y to function notation is very simple. You simply replace the y with f of x. So I have f of x equals x plus 4. And now I'm going to graph this function. So how does that work? Well, it's basically very simple. All you're doing up here, the vertical axis is your y, the horizontal axis is your x. Well, in this case, the vertical axis now just becomes f of x. We say the vertical axis is your function, and of course the horizontal axis is still x. And we do the same. We do the same thing. We go up here, here's our x-intercept. We step off. And there's the graph. Now we say this is the graph of this function. So the thing that's confusing now is it's going to just be in the way things are worded. We call this the graph of the function. This line represents the function. As a matter of fact, if I were to look at this graph and just say a few things, I would say, if I would say, where is the function greater than 0? If I look at this graph and I say, where is y greater than 0? Well, I would say, you know, obviously, this part of the graph, right? Because I'm looking, where is y positive? If I were to look at this graph and say, where is the function positive? In a sense, I'm saying, where is f of x positive? Or, in a sense, what I'm really saying is, where is the y positive? Well, obviously, that's where the function's positive. If I said, show me on this graph where the function is negative. Well, the function is negative where the graph is below the x-axis. If I were to say, show me on the graph where the function equals 0, well, the function equals 0, once again, this vertical axis is my function. So if I say, where's the function 0 at? It's going to be right here. That's just like up here, if I said, where on this graph is y going to be 0? I would say right here. So the word, when I keep saying function and y are interchangeable. Now, based upon that, you're going to have some problems in homework where they give you like a graph, and they're going to ask you a bunch of questions. And what I've done, I've went ahead and made a copy of the kind of graph that they're going to have you work on. And then I have a list of a bunch of questions based upon this graph. Now let's look at this graph for a minute. So it sort of starts here. You notice there's no arrow here, so the graph starts here, and it goes up, and then it sort of reaches a maximum, then it comes down, and it goes here, then it comes back up again, then it goes to here. And along the way, at sort of special points like this high point, this low point, a lot of times when the graph crosses the x-axis, or if it crosses the y-axis, they actually give you the coordinates of that point. And here's what's interesting, which can be sort of confusing. We're going to analyze this graph, and we're going to call this graph a function. But look at how they labeled this axis. They labeled it y. It's almost easier if they would have labeled the axis f of x, because we're calling this graph our function. So this is, you're given a function as a graph, and based upon this graph, you're going to be asked all kinds of questions about this function. So let me go down the list. Part A, they say find f of 0 and f of -6. This is function notation. This is like f of x. In a sense, it's saying go find the function, go find the value of the function when x is 0, and then go find the value of the function when x is -6. So I'm going to go to my graph. So for f of 0, let's go find the graph when x is 0. So x is my horizontal axis. 0 is right here. So right here, at this point on the graph, on the function, this is where x is 0. What's the value of the function? In a sense, what's the value? I could call it the y of this point, which is the value of the function is 3. So therefore, f of 0 equals 3. In other words, what's the value of the function when x is 0? The value of the function is, in a sense, the y value. Here's the point where x is 0. What's the y value? 3. That's the value of the function, right? Makes sense. The graph, at this point, the graph is 3. What about f of -6? You go on your graph and you find the point at which x is -6. It's down here, right? Here's this point. X is -6. What's the value of the function? What's the y value at this point? -3. So you say f of -6 equals -3. All right, I hope that's clear. Question B does a few more. First one is, what is f of 6? What am I going to do? I'm going to go on my graph and find the point where x equals 6, which is right here. And I say, what's the function at this point? What's the y value at this point? Looks like it's 0. F of 6 equals 0. And they also say, what is f of 11? So I'm going to go on my graph and find the graph where the value of x is 11, which is right here. And what's the function at this point? What's the value of y? It's 1. So for these first two examples, you'll oftentimes hear them use this kind of wording. What's the value of the function when x equals 11? That's what f of 11 means. What's the value of the function when x is 11? Sometimes they'll say, like this one, f of 6 equals 0. They'll say, what's the value of the function at 6? They'll just say that. What's the value of the function at 6? In a sense, what they're saying is, what's the value of the function when x equals 6? Now the next two, actually I'm going to skip, just do the ones that I think are useful or interesting. If I go to question E on here, here's the question: for what values of x is f of x equal to 0? For what values of x is f of x equal to 0? So basically they're saying go to the function and find all the points on the graph, all the points on the function where the function is 0, which means, all the points on this graph where y is 0. That's where the function is 0. As a matter of fact, where on this graph is the function 0? Well, right here, but also I've got one here. There are actually 3 separate points where the function is 0. You know what another word for these points are? Sometimes they like to call those X-intercepts. Remember X-intercepts? That's where the graph crosses the x-axis. That's what's going on here. This is where the graph is crossing the x-axis. So what are the values of x when this occurs? Well, this first one, x is -3. The second point, where the function is 0, x is 6. And the third time, where the function is 0, x is 10. So there are 3 values of x where the function is 0. Here's an interesting question. For what values of x is f of x greater than 0? What are they asking? They're saying go on this graph and figure out where the function is positive or greater than 0. So here's my function. If I think about the value of the function, when it starts out, what is the function? The function is -6. The function starts out being a negative number. It's below the x-axis. However, when it gets to here, all of a sudden, it's now the function's positive because it's above the x-axis. So for this whole sort of top hill here, the function's positive, and then what happens here? At this point, when the graph touches or crosses the x-axis, the function's 0, and then all of a sudden the function becomes negative again, and it stays negative for a while, but then it goes back up, and at the little tail, the function's positive. So what they're asking is, basically where's the function positive? Well, there's two parts. There's this big hump or hill, it's positive, and the little tail. There are actually two parts where the function is positive. And what they're asking is, what are the values of x when the function is positive? In other words, it starts here, the first positive section starts at this point and goes to this point, and they're saying, what are the values of x? Well, it starts here. At this point, the value of x is -3, and for all these values of x, it stays positive until you get to here. So basically, the function is positive from x equals -3 until x equals 6. If I write that as an interval, I would say if x is between -3 and 6, the function is positive. So that is this whole hump or hill there. But then I've got one more little section, this little tail, where the function is also positive. What are the values of x for this little tail? Well, it starts at x equals 10, and it goes until x equals 11. So I would, in a sense, union it with the little tail, which goes from 10 to 11. And actually, this is a little tricky. You know what 11 is? 11 should be an actual bracket. I don't include 10 because when x is 10, the function is 0. It's not positive. But here, up here at this point, when x is 11, the function is actually still positive, so I include 11. So what am I doing here? I'm trying to give the values of x where the function is positive, where the function is above the x-axis. What about if I say, same question for what values of x is f of x less than 0? In other words, go find all the places on this graph where the function is negative. So it looks to me like there are two negative parts of this graph. The starting point over here, it's negative, and then this little downward section here. So therefore, if I union those together, I start at -6, and this point is actually negative, so I do a bracket, -6. So when x is -6, the function is negative, and when until x gets to -3, the function's always negative. And then I union it with this little section here, which starts when x is 6, and it stays negative until x is 10. Now here's a question I ask. They ask, what is the domain? Now, we've talked about the domain of an equation, but what about the domain of a graph? And actually, the domain of a graph is actually a lot easier than the domain of an equation. Once again, the domain is what are all the possible values of x. And all you do is, you go to your graph, and since this is a continuous line, there's no breaks, there's no gaps, you simply say, well, what's the smallest value of x for this graph? How far to the left does this graph go? That's the smallest value of x. Well, this graph starts when x is -6. So it starts at -6. And then what's the largest value of x for this graph? How far to the right does this graph go? Well, it goes all the way to this point where x is 11, we would say the domain is the interval from -6 to 11. Although actually, I need to go ahead and make these brackets because it includes these 2 points. So the domain of a graph, very simple. What's the smallest value of x for the graph? And then the largest value of x. And as long as there's no gaps or breaks in between, straightforward. Now here's a word we haven't talked about as much, and that's the range. The domain are all the possible values of x. The range are the possible values of y. So when you have a graph, it's pretty easy to find the range, because once again the idea is, what's the smallest value of y? What's the smallest value of the function for this graph? Well, here it starts out at -3, and then it goes up and it comes down. When it comes down again, how far does it go? It only gets down to -2 before it goes up again. So what's the smallest? What's the farthest down this graph ever gets? -3. So then when you look at the value of y, how high, what's the highest point on this graph? Looks like the highest point's right here. And what's the value of y, or the value of the function? It's 4. So I would say the range is from -3 to 4. Once again, the range are the possible values of y. The domain are the possible values of x. And when you have a graph, it's very easy to see. The domain is the smallest value of x, the largest value of x. The range is the smallest value of y to the largest value of y. And the last thing we'll talk about here, they ask for the x-intercepts and the y-intercepts. X-intercept, you can think of the word intersection. Where does the graph intersect or intercept? The x-axis. Those are your x-intercepts. And actually, there are 3 points at which the graph crosses the x-axis. So I have 3 intercepts. The values of x are -3, 6, and 10. And if they ask you for the y-intercept, they're saying, what's the value of y when the graph crosses the y-axis? It's like there's one y-intercept right here, and the value is 3. All right, so this is a graph of a function, and these are the kinds of questions they're going to ask you to determine from the graph. And hopefully you see now that it's not really that hard, as long as you understand in your mind that the y-axis is like your function, and then you have the x-axis. So hopefully when you do these problems in the homework, you will not find them very difficult.